negative indices. Okay. So recall that law number 2 says if a to the power of m divided by a to the power of n would actually equal to a to the power of these two indexes subtracting each other. So m take away n. So let's see a situation where a to the power of 2 is divided by a to the power of 3. Then, by a simple calculation following index law 2, you should get a to the power of negative 1. What does negative 1 mean? Well, if we use our normal knowledge for division, we know that a to the power of 2 divided by a to the power of 3 should equal to 1 over a. So there we have it. A to the power of negative 1 equals to basically 1 over a. Well, how about we extend this? For example, a to the power of 2 divided by a to the power of 4 will also equal to a to the power of negative 2, which equals to 1 over a squared, right? So this expression equals to both, and therefore these two will equal to each other. So if that's the case, then we basically have a to the power of negative n will equal to 1 over a to the power of n. So this is what negative indices mean. It means that you're basically writing the reciprocal of a to the power of n when you have a negative in front of n. Okay? So then if that's the case, then what is a to the power of negative n? Well, you already see that it's basically a to the power of n. So it's kind of like the reciprocal of the reciprocal. How do we get there? We know that 1 over a equals a to the power of negative 1. So 1 over negative n is basically a to the power of negative n, the denominator, to the power of negative 1. And then applying law number 4, you stack them up. Or I think it's law number 3. You stack them up. So negative n times negative 1, that equals to a to the power of n. So for negative indices, we have the basic one, a to the power of negative n equals to, this should be equals to a to the power of 1 over a to the power of n. There shouldn't be a negative sign here. Okay? And then that also gives birth to this expression. Okay? So, examples. Let's express the following expression using positive indices only. Okay? So that's x to the power of negative 2. Then we know that straightforward application of the definition of negative indices, that equals to 1 over x squared. For b, a to the power of negative 2 is the only one that needs to be flipped. So it's equal to 3b to the power of 4 divided by a squared. Now express each of the following using positive indices only. Solution. Well, this one, we know 1 over c to the power of negative 2. We're using the derivation of the negative index, which means that's basically the reciprocal of the reciprocal is itself. Okay? And this one, for y, we're going to put it up. And for x, we're going to put it down because both of them are negative. So negative indices is basically if you were on the numerator, you got to go to the denominator. If you were on the denominator, you got to come up to become the numerator. This is what basically negative index mean. Okay? So that will equal to y to the power of 5 over x cubed. But for c, similarly, only 1 over y to the power of negative 4 needs a flip. So it equals to that. Okay. Now, can we express the following using positive indices only and then evaluate them? So negative 5, is that an index or is that a number by itself? It is not an index. It doesn't have to be flipped. It's just a number by itself. Yeah? Don't get distracted now. Every time you see a negative number, you have You gotta flip it. Only when that negative number is on the index, it's written as superscript, then it means you gotta flip the base number. If it's a negative number by itself, it's just a negative number. Okay? So leave negative 5 alone and flip 3 to the power of negative 2. Then you have 3 to the power of 2, and then it becomes negative 45. Okay. For B, use index law 5 to distribute the negative 4 first. So that would equal to that. And then, again, if you have a negative power, it means if you are on the numerator, you got to count to the denominator. If you were on the denominator, now you got to go up. So upstairs come down, downstairs go up. Then you have that.